All right, in this video, we're going to be working some multiple choice with the calculator, and I'm going to need to grab one. All right, so we're going to make sure our calculator's in radian mode, and we'll be good to go. All right, so this first one, this is not going to require the use of a calculator. It says the integral from 0 to 1 of f is 2, the integral from 0 to 4 of f is -3, and then they are going to ask you about the integral between 1 and 4, and so we're going to need to make a little diagram, okay? Okay, there's f of x, right? If it says that the integral from 0 to 1 is 2, well, that means that there's 2 units of area underneath the graph of f between x equals 0 and x equals 1. Okay, we know that realistically, if this is -3, then there's got to be some place where f is negative, but I'm not going to draw it like that because I think it's even easier to look at. It's probably going to need to be -5, right? If I add these two things together to get -3, well, I know that that integral is going to be -5. So then I hit this with integral properties. So this is the integral from 1 to 4 of 3 times f of x. Plus the integral from 1 to 4 of 2 dx. And then this, okay, this thing that I'm boxing off here, well, that's just the area underneath the graph of f between 1 and 4, so that's -5. And then 2x, as x runs from 1 to 4, will be, 2 times 4 minus 1. So I'll have -15 plus 6, and that's going to be -9. For which value of x is it true that f double prime is less than f prime, which is also less than f? And in general, with AP Calculus, when they have these like triple inequalities, and there's not really a whole lot of numbers for you to look at, it's going to be positive, -0, right? So I'm looking for a place where f double prime is negative, f prime is 0, and f is positive. Okay, so I'm looking for where the function is sad, flat, and above the x-axis. Okay, so sad and flat, that's looking like right there at x equals b. This one, the graph above shows the polar curve. What's the area of the region bounded? Okay, so I know that this is theta equals 0 right there. I know that this is theta equals pi right over here, so I'm going to be integrating from 0 to pi. And you need to remember that the polar area formula we got to know is 1/2 r squared d theta. Okay. And now I'm going to have to type that into the calculator. But I'm not going to switch to polar mode for that, right? Because I can just use x instead of theta. So 1/2 of the integral from 0 up to pi of 2 theta. Oh no, this is in polar mode. That's not a good sign. I'm going to length this one out. Hardly ever is it the thing to do to go into polar mode. I won't say never, but pretty much never. It's going to be when you're going to want to go other modes. Plus cosine x squared dx. 17, 4, 5, 6. There it is. That's choice D. Right, number 79. F is a differentiable function with f of 3 is 8 and f prime of 3 is 5. Which of the following statements could be false? Okay, well, if it's differentiable, then we know it's continuous, so that means that the limit of the function has to be the value of the function. Okay, that must be true. Okay, the limit from the left equals the limit from the right. Well, I know that the limit equals 8, so it must be equaling the same thing from both sides. This also must be true. Okay, this is the limit of rise over run as run goes towards 0. That's the slope, that's the derivative. Okay, f prime of 3 is 5, that must be true. Again, this is a different version of it, but this is f prime of 3. Rise over run as run goes towards 0, that must be 5, because they told us that the slope is 5. This must be true. And then the limit of f prime of x equals 5. Oh, man. This is another one of those where I've told you before, you need to be aware that it is possible for the derivative to exist and not be continuous, but it's exceedingly rare. Okay, so that's where this, and this one you're definitely best off going on process of elimination, because the first four are pretty obviously must be true, and so you choose the fifth one and move on. Okay. Figure here shows f prime. If the derivative is given by h prime is 2 times f prime. Okay. Well, points of inflection, if it's h prime is just twice as big, well, we switch this to y equals h prime of x, and I'll turn that into a 2, and that into a 4, that into a negative 2, and that into a negative 4, and now I've got a graph of y equals h prime of x. Okay. And how many points of inflection does h have? Well, that's going to be extrema on the graph of h prime, right? Any place where h prime is increasing, h is concave up. Here where h prime is decreasing, the slope is decreasing, that's what it means to be concave down. So I've got a point of inflection there. Over here, I've got another point of inflection because h prime is decreasing and then increasing. These extrema on h prime are points of inflection on h because they're changes in concavity. So I'm seeing 2 on the interval -3 to 6, 2 direction changes. All right. Then we're going to let R be the region in the first quadrant bounded by the y-axis, the x-axis, okay, y-axis, x-axis, the graph of e to the -x squared divided by 2. Let me think about that. Okay, well, it's just e to the -x squared. It's just going to decay. I think it might have, like, maybe a point of inflection in here or something, but you don't really need to worry about that. And the line x equals 3. Well, e to the -9/2, well, that's going to be pretty small. I'm going to just say that's there. Region R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis is a square. Okay, so that's the base of my square. Okay. So the area of a square is equal to base squared. In our case, base is equal to top minus bottom, so that's going to be e to the -x squared divided by 2. Top minus bottom is y equals 0. That's the x-axis. And then we know we need to integrate area formula to get volume, so that's going to be e to the -x squared over 2 squared as x runs from 0 to 3. And then that's going to be a job for the calculator because we don't have an antiderivative for e to the -x squared with respect to x. Okay, so I'm going to go in here, I'm going to integrate from 0 up to 3 on, if you want to simplify that before typing, you can do that, but I'm just going to type it in just how I see it, divided by 2, square that, integrate with respect to x, and I get 0.886. And there it is, answer choice A. Number 82. If f is continuous on the closed interval a to b, which of the following must be true? Okay, what I know about a continuous function on a closed interval is that it must take a maximum and a minimum value. Okay, and also, you know, the intermediate value theorem goes off of continuity, but continuous on a closed interval, probably going to be, yeah, that is going to be it, right? There is a place, a c is an x value between a and b, such that f of c is bigger than or equal to f of x for all x in the closed interval a to b. Okay, if you draw any sort of continuous function like that, okay, there's going to be some place, at least once, where f is always less than or equal to that, right? Like, who knows, maybe I send it back up over here and we hit it twice, but nothing's bigger than that. That's what it means. Okay, number 83. F is differentiable and has values as shown in this table. F and f prime are definitely strictly increasing. Okay, I can see that. Which of the following could be the value of f prime of 3? All right. So what we're going to do is we're going to do rise over run on kind of like these two intervals here. And then we're going to say, well, since it's increasing, we'll probably be able to pin one of these numbers in between the two numbers that we're going to get with our computations. So I'm going to say, on one hand, I'm going to do rise over run with this. So, you know, since I've got the calculator allowed to me, might as well do it. So 39.2 minus 31.25 divided by, nope, that's not what I wanted. right? If you're not sure, write in 3.0 minus 2.8. I'm certain. Okay, that's 29. Okay, then over here from 3.0 to 3.1, I'm going to have a rise over run scenario like 4805 minus 45. Okay, I'm not great with arithmetic, but I'm good enough that I can do that. Divided by 0.1, and then that's going to be 30.5. All right, so over here my estimate for f prime is 29. Over here it's 30.5. So I feel like it's got to be between 29 and 30.5, which is going to be 30. Basically, since it's differentiable, and I did the average rate of change over 2.8 to 3.0, and it came back 29, I know for a fact that f prime equals 29 somewhere between these two. But specifically, f prime is equaling 29 before x equals 3. And if f prime is increasing, then f prime of 3 has to be bigger than 29, which is 30. And then you can do the same reasoning with over here. Getting 30.5 for your average rate of change means that f prime has to equal 30.5 somewhere between 3.0 and 3.1, meaning that f prime of 3.0 has to be less than 30.5. All right, here we've got a logistic differential equation scenario. So you need to activate all of those trivia facts that you know, right? Like basically, maximum growth rate happens at half the carrying capacity. The form of the differential equation, I think, is what we actually need this time. So what we need here is we need dp dt is number times population times carrying capacity minus population. Okay, maximum number of people allowed on the beach is 1,200, so I'm going to plug in for L. Okay, so just based on the form, I can get it down to these three, right? This doesn't have the extra p on the outside. This has the extra plus 200 and does not have the p on the outside. So I'm going to get rid of these two. Okay, so now the question is, like, which is this? But it said at 10 a.m., which the fact that it's 10 a.m. isn't important. It's just like at a particular time, the number of people on the beach is 200. Okay, so when p equals 200, the rate of change of p with respect to time is going to be 400. Okay, so now I'm going to say, all right, I'm going to basically say 400. I'm just trying to solve for k is equal to 200k times 1,000. Okay, so I can tell that, all right, I'm going to start by dividing 400 by 200, and I'm going to have 2, and then I'm going to divide by 1,000. And that's going to be 1 over 500. 2 over 100 is 1 over 500 times p times 1,200 minus p. All right, 85. The third derivative of f is continuous from 0 to 4 values. Okay, we're going to need to do probably 2 orders of L'Hopital's rule, I think. Okay, so f is approaching 0. 2 minus 2 squared is also approaching L'Hopital's rule. So now I'm taking the limit as x approaches 2 of f prime of x divided by, take the derivative of the bottom, 2 times x minus 2 to the first, times 1 for the chain. All right. And now this f prime is 0, and 2 times 0 is going to also go to 0. So, still going to 0 over 0, not equal 0 over 0. It's going to 0 over 0. We're going to use L'Hopital's rule again, but nobody's checking my multiple choice booklet for the quality of my work, so I'm going to call that f double prime divided by 2, right? Because this would be 2x minus 4, and the derivative of 2x minus 4 with respect to x is just going to be 2. And then f double prime is 5. I've got divided by 2 from down there. That's going to be 5 halves. I'm ready to move on. Okay. I gave you all this problem on a test recently. Okay. What's the value of f's 30th derivative at 3? Here's the Taylor polynomial. We know that we're going to get the information about the 30th derivative from the 30th power term. Okay, so I need to look for x to the 30th. That's going to be where n equals 15. Okay. Negative 1 to the 15 plus 1 is 16 times x minus 3 to the 2 times 15 divided by 15 factorial is equal to f's 30th derivative at 0, which is what I'm hoping to find eventually, divide by 30 factorial times x minus 3 to the 30th power. Okay, I'm going to divide both sides by x minus 3 to the 30, multiply both sides by 30 factorial, and I'll get f's 30th derivative is going to be equal to 30 factorial divided by 15 factorial, and it's going to be positive because it's negative 1 to the 16th power. Okay. Oh, the Lagrange error bound question. This was one that I had intended to give y'all like in the examples or somewhere, and we just never did it, I don't think, in the notes. And so I'm glad it showed up here. So this is f's fourth derivative equals e to the sine x. Okay, we're going to use a third degree Taylor polynomial for f around x equals 0 to approximate f on the interval 0 to 1. Okay, what would be the maximum possible error? Okay, well, I know that if I'm using a third degree Taylor polynomial, the Lagrange error bound is like the maximum possible value of the next term. Okay, so it's the maximum of the absolute value of f's fourth derivative divide by 4 factorial times the absolute value of the x value we want to plug in to approximate minus the centering value. It's centered at 0 to the 4th power. Now, the biggest that we could make this would be if x was equal to 1. If we were plugging in x equals 1 into our third degree Taylor polynomial, right? If x is 0.2, you take that to the 4th, that's going to be really small. Okay, so the biggest this is going to be is 1 to the 4th. Okay, the maximum possible value of f's fourth derivative, well, we're going to graph this, but this is one where I need to be very careful to say, all right, x is in the interval 0 to 1. Okay. So if you, and I think the first-time calculus student should definitely run the graph of e to the sine x. Okay. And we're going to set the window to 0 to 1. And I've got to think that, yeah, that'll be a decent window. Okay, it was increasing the whole time. So the maximum value I'm seeing is over here at the right edge. I'm going to calculate the value of the function where x equals 1, and I'm going to get 2.319. Okay. Or 2.32, let's just say 2.32, but then we're dividing by 4 factorial, and I'm going to get 0.097, and that's going to be the error bound. Okay, so for me, when I've seen this problem in the past, and I'm like, oh, I know that sine of x is strictly increasing on the interval 0 to 1 because sine increases from 0 to pi over 2, and 1 is less than pi over 2. Okay, so I know that I can just plug in e to the sine 1 to get that maximum of f's fourth derivative, but if you're not seeing that, then you should just graph it because you're allowed to use a calculator on this problem anyway. That one's not your standard Lagrange error bound problem, is what I'll say. This is a standard average value problem, though, because the rate at which water is sprayed on a field is R. What's the average rate of water flow? So it's going to be the average value of R. We know how to do that. We're going to integrate R from 0 to 4. And then we're going to divide by 4 minus 0. That's how we take an average. We add them all up, and then we divide. So this is going to be equal to, well, I guess I don't know. I'm just going to use a calculator for it. So it's 1/4 of the integral from 0 to 4 of r of t. So this is the square root of 1 plus 5 t to the 3 dt. 14,691. There it is. Okay. All right, which of the following has the greatest value? We've done this problem. It's been a long time, though. So f of a. That's a negative number, so I can't think that's going to have the greatest value. F prime of a is pretty steep. Yeah, that's the slope of that tangent line. It's pretty steep. Yeah, that's definitely positive. F prime of c, that's the slope at c. That's going to be 0. Right? F of d minus f of c is a lower number minus a greater number, so that's going to be negative. And f of b minus f of a over b minus a, well, that's the slope between points a and b. And that's why I brought out the ruler, because I know about this. Okay, so this is like the slope of the tangent at point A, right? And we see it's concave down, so the slope's decreasing. So if I had to get it so that it fit both of these points, I'm going to have necessarily a shallower slope. So I know that this is also positive, but it's less than how positive f prime of a is because the concavity of this thing, it's angry, it's frowning. All right, and then number 90, what is the Maclaurin series for f? Okay, I feel like the could have maybe given us something a little more difficult, but let's see, how many terms do I need? Maybe, it looks like, oh, they're all kind of, they're all similar enough that I'm going to need to do a couple of terms. I think none of these second and third terms are identical, so I'm just going to go off of n equals 2 and n equals 3. Okay, so we know that it would start out with f of 0 plus f prime of 0 times x, but then it's going to be f double prime of 0 divided by 2 factorial x squared, f triple prime of 0 divided by 3 factorial x to the 3, right? And because of the differences in these answer choices, I'm going to be focusing on these two terms here. Okay, so f double prime of 0 is n equals 2. Is negative 1 to the 2 times 2 plus 1 divided by 2 plus 2 times 2 to the 2. Okay. Then I'll have negative 1 to the 3 when n equals 3 times 4 divided by 3 plus 2 is 5 times 2 to the 3 is 8 by 3 factorial x to the 3. Maybe this is why it was number 90. On an arithmetic level, it's a little much. So that's going to be 3 over 16 divided by 2 is going to be 3 over 32. And it's going to be positive 3 over 32. So I've got this one's out. Those two are also out. Okay, so the next one is, it's going to be a minus because it's negative 1 to the third power, so I know that's going to be answer choice D. And that's, I think, probably the fastest way to do that is to just click, identify how many terms you need, go for those terms, eliminate based on properties. Okay, that's going to be all for this. Thanks for watching.